Hello everyone, I am Pasupuredi Lavanya and I am going to cover the topic flow control mechanism in data link layer. There are a lot of restrictions to send data in a transmission medium. Flow control is a speed matching mechanism that coordinates the amount of data that has been sent from sender before receiving acknowledgement by the receiver. Receiver has a limit speed at which it can process incoming data and a limited amount of memory, that is buffer, in which to store incoming data. The rate of processing is often slower than the rate of transmission. Receiver has a block of memory for storing incoming data until they are processed. First transmission, we see that frames are sent from source to destination without being lost, corrupted, or damaged. In the second transmission, we see that the frames are being lost and corrupted. Frames being lost, corrupted, and damaged has to be retransmitted, and transmission is called error control. Error control includes both error detection and error correction. ARQ, automatic repeat request, is an data link layers error control technique. When error is detected, specified frames are retransmitted. In a data link layer, the flow control mechanism is done in two channels, noisy channel and noiseless channel. There has to be used ARQ, automatic repeat request or automatic repeat query, which is divided in two categories, stop and wait ARQ and sliding window ARQ. Sliding window ARQ is further divided into two categories, go back and ARQ, selective repeat ARQ. Here, in this transmission, we see that data is transferred from sender to receiver in the formats of frame. Frame 0 is received by the receiver and acknowledgement 1 has been sent from receiver to sender. That it tells the frame 0 has been received by the receiver successfully and it is waiting to get frame 1. The sender sends the frame in zeros and 1 frames and get the acknowledgements 1 and acknowledgement 0. Stop and wait ARQ has three conditions. Lost acknowledgement frame. In this transmission, we see that sender is sending the frame 0 and receiver receiving the frame 0 successfully. So, transmitting the acknowledgement to the sender. And then sender is sending the frame 1 to the receiver and receiver is getting a damaged frame. It discards the damaged frame after the timer at the sender expires. It is 5 microseconds. The sender again retransmits the frame 1 and waits for the acknowledgement received by the receiver. This is the second case where sender has sent the frames to the receiver but the acknowledgement of the receiver has not been received by the sender. In this, receiver has sent the acknowledgement to the sender, but the acknowledgement got lost in the main process. So the sender again retransmits the frame 1 and gets the acknowledgement. It discards the frame 1 which is duplicate. Receiver has already received frame 1 and expecting to receive frame 0. So it discards the second copy of frame 1. This is the third condition, which is delayed acknowledgement. The acknowledgement can be delayed at receiver due to some problems. It is received after the timer for frame 0 has expired. So sender retransmits a copy of 0. However, receiver expects to see frame 1. So receiver discards the duplicate frame 0 and sender receives the second acknowledgement. It discards the second ASIC. Disadvantage of stop and wait is in this transmission we can only transmit one frame at a time and waiting to be acknowledged. This is not good use of a transmission medium. To improve efficiency, multiple frames should be in transition while waiting for acknowledgement. To overcome this, we have two protocols to use, that is on basis of sliding window ARQ. Go back in ARQ. We can send up to n frames before worrying about acknowledgement. So the receiver keeps the copy of the frames until the acknowledgement arrives to the sender. This procedure requires additional features to be added to stop and wait ARQ. In a sliding window, sequence number are frames from sender are numbered sequentially. We need to set limit since we need to include the sequence number to each frame in the header. If the header of the frame allows m bits of the sequence number, then the sequence number range from 0 to 2 power m minus 1. If m is equals to 3, then the sequence number would be from 0 to 7. We can repeat the sequence number. In this frame, we see that window size is 7. At the sending side, to hold outstanding frames until they are acknowledged, we use the concept of window. After transmitting the frame, the window will be waiting for the acknowledgement received by the receiver. After receiving the acknowledgement, the window starts expanding from the right side. At the receiver side, sliding window, size of window at the receiving site is always 1 in this protocol. Receiver is always looking for a specific frame to arrive in a specific order. Any frame arriving out of order is discarded and need to be resent. Here, receiver window is waiting for frame 0 to send by the sender. After receiving frame 0, it slides the window to the next frame. Receiver sends positive acknowledgement if a frame arrived safe and in order. If the frames are damaged or out of order, receiver is silent and discarded all the subsequent frames until it receives one in the expecting. Here we will see an example for go back and ARQ using sliding window. Here the sender keeps track of sending frames and updates the variable and the windows as the acknowledgement arrives. Here we see that in this transmission, sender and receiver has windows. Here in this transmission, we see that sender and receiver are transmitting frames and getting the acknowledgements. Here in the sender side, the sender has sent the frame 0 and 1. After that, it acknowledges that saying it has received frame 0 and 1. Here in this transmission, we see that frame 0 and frame 1 is sent to the receiver, and receiver sends the acknowledgement to telling that it has received frame 0 and 1 successfully and it is waiting to receive frame 2. So the sender starts sending the frame 2 and it gets acknowledged that it has sent the acknowledgement. Sender has sent the frame successfully. Receiver has received the frame successfully and waiting to receive this frame 3. Here, as the frame is getting acknowledged, the window is also shrinking from the left side. In this transmission, we see that sender and receiver are transmitting frames and getting acknowledged. Here, frame 2 has been lost. When the receiver receives frame 3, it discards frame 3 as it is expecting frame 2 according to window. Frame 3 is discarded. After the timer for frame 2 expires at the sender side, the sender sends frame 2 and 3 and it says go back to 2. Here this is the go back and ARQ that has lost frame. If the frame has been lost, the sender will send the frames from the beginning from where the frame has been lost. In go back and ARQ, the process at the receiver side, receiver only keeps the track of only one variable. There is no need to buffer out of order frames. They are simply discarded. However, go back and ARQ protocol is inefficient for noisy links. In selective repeat ARQ, only the damaged frame is resent. More bandwidth efficient but more complex processing at receiver. It defines negative acknowledgement as NAK to report the sequence number of damaged frame before the time expires. Here in the sequence, we have window for the frame transmission. In this selective repeat ARQ, we see that in this transmission, sender is sending the frame 0 and frame 1 to the receiver. Receiver has received 0 and 1 frames and gives the acknowledgement to the sender that saying it has received frame 0 and 1 successfully and waiting to receive the frame 2. So the sender starts sending frame 2 after expanding the window and shrinking the frames that has been sent to the right side. Here frame 2 has sent to the sender, but in this process the frame has been lost. Frame 0 and 1 are accepted when received because they are in range and specified by the receiver window. Same for frame 3. Receiver sends a negative acknowledgement to show that frame 2 has not been received, and sender resends only frame 2 and it is accepted as it is in the range of window. Here, in the selective repeat, if any frame is lost, then the sender gets negative acknowledgement of that frame and it transmits only the frame that has been lost, not every frame that has been lost after it. Thank you.